oxidizing and reducing agents is that oxidizing agents reduce things and reducing agents oxidize things. So we need to look at is what exactly happened here. Now you can look on this side and see we have ClO3 minus, we have over here we have ClO2. You're gonna have to look and see if this was reduced or oxidized. We can do that by calculating the oxygen state of the chlorine on both sides, because we know that the oxygen won't change. So on this side we'll have negative 2 times 3 plus x equals negative 1. So we have x is equal to negative 1 plus 6. X is equal to 5. Negative 5, that is. Now let's look on this side. We have 2 times negative 2 plus x is equal to 0. So we have x equal to 4. But clearly the chlorine was actually reduced in this case. Therefore, you need an oxidizing agent for the reaction to have occurred, because you need an oxidizing agent to reduce it. So on to the next one. So here we have sulfur 2 minus, and then we have sulfur 2 minus here. Now again, we can use the same method we did before to find out if there was a reduction or an oxidation. So for this one, on this side we can say 4 times negative 2 plus x is equal to negative 2. You can say that x is equal to negative 2 plus 8, i.e. x is equal to 6. So sulfur over here is plus 6, but over here we have the sulfur as 2 minus. Therefore we can say that the sulfur was reduced and you need an oxidizing agent to have done this reaction. For this one, we have Mn2 plus on this side and MnO2 on this side. You can go ahead and calculate the oxygen state of Mn in MnO2, and what that would be negative 2 times 2 plus x is equal to 0. Therefore x is equal to 4. But over here it was 2. Therefore it was oxidized, and therefore we need a reducing agent to carry out this reaction. Similar method can be applied to part D. Let's go further. Okay. Chlorine is formed when KMnO4 reacts with hydrochloric acid. The ionic equation for this reaction is 16H plus 2MnO4 minus plus 10 chlorine minus 2Mn2 plus H2O plus 5 chlorine. Okay, so chlorine is formed when KMnO4 reacts with hydrochloric acid. The ionic equation for this reaction is 16H plus 2MnO4 minus plus 10 chlorine minus reacts to give 2Mn2 plus H2O plus 5 chlorine molecules. Deduce the half equation for the oxidation of chloride ions to chlorine. Now this is quite simple. We're going to have chloride ions, which are Cl minus. We can draw the arrow and say that these are gonna become chlorine molecules. But how will they become chlorine molecules? Well, the chloride ions, chlor- the chloride ions have a negative one oxidation state, but the chlorine atoms will in the molecule will have a zero. So we're gonna have to take away the electrons. So we're gonna have to say minus E, minus to represent electrons, and but we have two chlorines over here, so we'll have to go ahead and put two there and put a two there to balance it. Very simple. Now this one here give the oxidation state of the manganese in the MnO4 minus ion. Quite simple. All I have to say is that negative 2 times 4 plus x is equal to negative 1. So then we can say that x is equal to negative 1 plus 8. Therefore, x is equal to positive 7. Positive 7 is the answer. This one here, deduce the half equation for the reduction of MnO4 minus ions in acidified solution to manganese 2 ions in water. So we have the MnO4 minus 1 ion in acidified solution, and we can draw the arrow. Always leave space for the other things you plan to write in. And it says it goes to the Mn2 plus ions plus water. Now, the water, you're going to account for where the oxygens end up. So we know the oxygens end up in the water. And there are 4 oxygens, so we can go ahead and put a 4 here. But now we need to figure out the hydrogens. In an acidified solution, there will be hydrogen ion dissociated. So we can say that we can just add in hydrogen ions to account for the hydrogens on this side. And we end up with H plus. But there are 8 hydrogen atoms over here. 4 times 2 is 8. You have to put back an 8 in front of this. But there is still a problem. The charges are unbalanced. Over on this side, we have a positive 7 charge, 8 plus, and the minus 1 of positive 7. Over here, we have a 2 plus. Therefore, we're going to have to add electrons, 5 electrons, to balance all the charges. So we have 6 minus 8 plus, so we get 2 plus. I have 2 plus over here, therefore it's balanced, and so this is the equation you'll want. Right, let's move on further. Chlorine behaves as an oxidizing agent in the extraction of bromine from seawater. In this process, chlorine gases bubble through a solution containing bromide ions. Write the simplest ionic equation for chlorine with bromide ions. So I'm going to go ahead and we're going to write chlorine, gaseous form of course, Cl2 plus the bromide ions, Br minus, and it says that chlorine is an oxidizing agent in which it will oxidize the bromide ions to bromine. So I end up with Br2, and when it does that, it will end up being reduced itself to chloride ions. And so all we have to do now is balance the equation by putting a 2 here and putting another 2 here. Okay. One observation that will be made during this reaction: bromine in its natural state is a reddish brown liquid, so the solution would change to reddish brown. And the final question, in terms of electrons, the meaning of the term oxidizing agent. Now, an oxidizing agent is the compounder element that gets reduced. The oxidizing agent gets reduced and reduction is gain of electrons. The oxidizing agent is the component element that gains electrons. That will be all the questions for this segment. Thank you for watching.